Hello, everyone, and welcome back to NetApp On Air. As always, I'm your host, Nick Howell. Thank you for joining us for this season finale, I guess, of the year. This is our final episode of 2024. As we get into the holiday season, everybody's going to start taking breaks and all that stuff, and we take breaks too. So we're going to be taking one, but that shouldn't stop you from getting into our Discord community, because that's going to keep going 24/7 all the time. Make sure you get into there, because that is the place to be. It's where you guys want to be hanging out. All of your peers are hanging out in there, helping each other solve problems, learning about new features and functionality, updates to products, all of that kind of stuff. And Drew and I hang out in there with the rest of the community. We've got our partners in there. We've got some of our executives hang out in there, our support staff, everybody. So discord.gg/netapp, or just head to netappdiscord.com. Read a little summary, click join, all that good stuff is over there. We should also say that we're seeing quite a few of you watch and listen on Spotify now. Yes, NetApp On Air is now available on Spotify. You can listen to just audio, or if you can also watch the video over there as well. So come follow us over on Spotify if that is a preferred listening or viewing platform for you. We have that available for you. Just know that it'll be a couple of days delayed normally from the YouTube version, just because we have to upload it and all that kind of good stuff. But yes, come find us over on Spotify. I'm sure super producer Drew will throw a link in the chat for us to the show if you'd like to go find it, or just search for NetApp On Air. You'll find us there. Just look for this big beard over there. I wanted to start off today's show before we get into the meat and potatoes of today's episode. This is going to mark the end of the second year of the show. We've been doing this for 2 years now. We've got well over, I think, 50 episodes in the can, and really have enjoyed doing this. And I've got some ideas of things that we want to do for next year, and I want to share all of those with you. So as always, Drew and I will likely do at sometime early January, we'll come back and do our community update, annual tradition at this point. And going into year 3 of NetApp On Air, looking back at some of the things we did over the last couple of years and some of the things we want to do going forward. But I just wanted to say thank you all for following along with us, for joining us here on the show. Stick with us. We're going to do lots more stuff, just like what we're going to be talking about today, going into the new year and beyond as well. So without further ado, I wanted to set up today's episode. I have to wholly admit that I have not worked with this feature of ONTAP before. We're going to be talking about FlexCache today. Of all of the Flex and Snap words, it's probably the one that I have the least amount of knowledge and experience with, personally. It wasn't available when I was a customer. I would have killed for it, because we had 27 different sites around the United States serving home drives and departmental shares and various things like that. And boy, that would have been amazing if we wouldn't have had to stand up so much bandwidth between all of the sites for people to access all of that from one central location over the pipe. So I think some of the things that we're going to talk about today are related to that. But let me bring on my guest today. I've been trying to get him on here for quite some time now. Very excited to have him finally as we get into the end of the year here. He is our TME for Manageability Products, Mr. Elliott Ecton. Thank you for joining us, man.
Hey, Nick. Thanks for having me.
I know you're a little bit under the weather today, but just wanted to give you a big shout out and big thank you for still sticking with us and joining us today.
Yeah, absolutely. As long as I can talk, man, I'm good to go.
So tell us about yourself. How'd you get started at NetApp, and how'd you find your way into FlexCache? What enticed you about that?
Well, you want me to start with FlexCache or start with how I got it at NetApp? So
let's start with you.
Okay. Yeah. So I started here about 11 years ago, actually, as a student contractor. I was doing QA for our E-Series product. Nice. Did that for about a year. I got bored with that pretty quick. It's just not my cup of tea, right? So I moved on to our support center, where I became a escalation engineer for our NAS vertical. Then you may know August Ritchie. This is inside information, but he was above me, right? So I got to a point where it's like, man, if I want to progress my career, I'm either gonna have to make August disappear somehow, or I'm gonna have to do a lateral move. And so I ended up doing a lateral move, became TME for all things NAS, and then they're like, oh, by the way, you are going to do FlexCache as well. So it's pretty much everything I do now is FlexCache. I still do NFS, TCP/IP, all that stuff, but FlexCache is a very hot topic, and it takes up most of my time.
Well, it's almost like you have to know those fundamentals to understand and really take advantage of FlexCache in a way. You really have to know that stuff to
Yeah.
get into those.
Yep, for
So
sure.
I love talking with our TMEs as a former one myself because I understand the vast diverseness of that role. You're not only presenting and educating, but you're also doing sales engagements. You're presenting at trade shows. You're doing all of these kinds of things. It's a very jack of all trades kind of role that requires a special skill set. And I've always got a lot of respect for it. And always want to highlight all of you guys and girls. So FlexCache. Let's get into where do you typically. All right, I'm a new customer. I've just bought my first NetApp storage system. How do you? I barely know. I've scratched the surface of ONTAP. I kind of understand snapshots. I've seen the ABC diagram. I kind of get it. But how do you get me to the point where FlexCache is something that I'm starting to understand? How do you introduce it to people that have never heard of, really worked with ONTAP before?
So I mean, it's really just an extension. It's almost an extended volume, right? So can I bring up a diagram? And I can
Yeah,
show
let
you
me
there.
pull this up for you here. There you go.
Cool. So yeah, basically, this is my first slide when I'm introducing it to people, right? So that little circle in the middle, that's kind of your origin volume, and these are all ONTAP clusters in here. Okay, so that origin volume in the middle can be extended out to those purple caches anywhere, and it's not a sync and share kind of, rsync. There's other caching technologies that it just makes a copy of the file, then you got to merge it back in and do, conflict remediation, all that stuff. We don't have that with this. Like the origin, it orchestrates access to the files, and basically you will get local access to your files no matter where you are in the world. So you just have to cluster peer, and then you just start rocking and rolling. It's just like a regular CIF share at that point. So you get local access. So it's good for geographically dispersed workforces. And there's also another use case for accelerating hot data. So
yeah. So my use case that I would have had back in the day would have been local access to home drives on remote sites and things like that. Right?
Yep, you got
that's the kind of stuff that I tend to think about when I think about local caching technologies. I also think about same day game releases globally. I think about things where they would want to like pre-stage binaries for download or something like that. That's the kind of stuff that I tend to think about when I think of globally dispersed local access.
Yeah, I get that. I actually haven't had any kind of that staging, local staging for downloads, but yeah, that's actually a good use case.
Yeah. Okay, so let's continue the story. I understand. So are each of these? You said they're not sync and share, but are you said the purple ones represent other clusters, other systems in the cluster?
No.
Does
go ahead. Oh, okay. Yeah, they can. So each one of these, they're actually volumes. Okay. And each one of these purple ones, they reside in a different cluster. So the center one is the origin, is kind of the single source of truth, right? And it's also the orchestrator for access to the file. But all these purple ones, they can be any distance from the origin. You just have to cluster peer. So you have one, let me see if I can get. So through this one, it has to be cluster peered to this, right? But this can be on the opposite side of the world as the origin. And it will actually have the exact same data, and it will always be 100% consistent, coherent, and current, no matter what you're doing. So, and you can have up to 100 of these purple circles, and they could be any distance from that origin, and everything is going to maintain its consistency, concurrency, and coherency.
Gotcha. So how are these typically interconnected? Are they going out over encrypted lines over the public internet? Are they dark fiber connected? I mean, as long as they can talk to each other, it doesn't matter, right?
Yeah, it doesn't matter. I mean, you obviously, a dedicated pipe is better, but you can actually go over the internet too. So it's just TCP traffic in between. It's TLS encrypted TCP traffic, but it is TCP IP. Yep. So it's actually the same thing as SnapMirror. We use the same thing for same ports even as SnapMirror.
Gotcha. So are we're just moving blocks, or like, okay, so does an entire volume get sort of represented on that remote, or is it block by block? How does that, I guess that's the part that I don't truly understand. What gets shipped over the
Yeah.
pipe and what stays locally?
Okay. So when you first set up one of these purple circles, right? So you set
Mhm.
up a FlexCache. When you connect to it via, I'm a Linux guy, right? So you get on there with you mount the NFS share or the NFS export, and you do an LS. You're going to see everything. The whole file system looks the exact same as it would as if you're enumerating the origin directly, right? But those are all sparse files. There's not a single block of data in them. It's just the metadata, so you can see what you got. So FlexCache is a pool technology. We don't ever push data just because. And that's a good thing because it helps eliminate bandwidth. We only pull data that is actually requested. And we can do that down at the block level. It's not even at the file level. So if someone wants just the, for tools and libraries, if they just want a little section, a function of a tool, and that's all that the program requests, that's all that's going to cross the WAN. So we're not going to pull the entire file or anything like that.
Gotcha. So that's the difference really between, so we're not doing a full initialization replication that SnapMirror does, but similarly, we're only pulling over blocks at a time. It's just based on when they're accessed. Got it. Okay.
Yep, you got
so
it.
If someone in accounting at a remote site opens an Excel spreadsheet, it's only going to pull the blocks over that are requested from that spreadsheet.
You got it. Yep.
Nice. But to the end user, the experience is there a one-time initial hit lag latency as it loads?
Yeah, there is. I've got some slides if you want me to show you with some animations that show that.
Yeah, let's step through it.
Okay. So let me get
I don't want to jump ahead too much. I'm just asking questions as they come to me.
Yeah, no problem. Let me get over here. Sorry.
No worries.
Did it go away? It did not go away. Cool. Sorry. All right. So this is essentially, I will get there eventually. As you can see, there's a lot of stuff. All right. So this is a first read, right? So
yeah,
you'll see that over here, the origin has data, and you can see the file, but there's no data blocks in it, right? And so if a client requests data at the cache, it's going to forward that request for the first read because it's got to fetch them, because we don't, like I said, we don't push anything. It's always pull on demand. And so once that is populated, then the next read, as long as that data is valid, we're going to be able to service that locally. So and we have data delegations and other things like that will always guarantee that you won't access a stale file at the cache. You will always access the latest data.
So if they are accessing something, but there's been an update to it, how are you doing the consistency check between the origin and the local?
So we have a couple of concepts that you kind of have to understand to get that. But the one for that is called a data delegation. So the origin knows everything that it has cached out, right? That these caches have, and it knows each file where it is and what's state it's in, right? So if there's a data delegation that is given out to each cache for each file, and as soon as that file in that data delegation basically says, hey, this is safe to serve, right? This is the latest data, you're good to go. So the cache never has to check back in with the origin. But as soon as that data is changed anywhere on any cache or the origin itself, it's going to go out and it's going to actually revoke that data delegation. So next time that someone comes in to try to access that, the data delegation has been revoked. So it knows, the cache knows, hey, I've got to go back to the origin to retrieve the latest data.
Clever. So we're never really pulling data blocks across, or sorry, we're never pushing data blocks across, but the origin will keep everything that it is peered to updated, as far as just to let it know, like, hey, it's been updated. The next time you get a request, you need to come back to origin.
Yeah, I kind of like to say it's updated just in time, not just in case. So
I like that. Yep. Okay. So where do we go from here?
I don't know. What do you want? How deep you want to go?
Okay. Yeah, I want to go. Let's keep going down the rabbit hole. So I'm looking at this going beyond the basic use cases. What are some of the things that you've seen people really excel at doing this kind of stuff with
so
FlexCache? What else do we need to know about it?
So it's really big for EDA, right? Bursting into cloud, so design anywhere kind of layouts. It's really big for that. Rendering is high performance compute, right? And it's very, very heavy on specific files, so you get really bad hot spotting. And so you can actually collapse the cache down into the same cluster as the origin, and now you start making, more affinities to be able to access that data. And so it's kind of like load sharing mirrors back in the day, but more intelligent load sharing mirrors. That's a good one. Obviously, the home drives, all that stuff, the geodispersed workforces. We've seen a big uptick since we've not got rid of, but announced the end of life for GFC, right? So architect firms use GFC pretty heavily in their SMB workloads, and they're starting to come over to FlexCache. And so that is actually, multiple people working on the same project. They may be working on the same file too, but it without the locking and everything is kept current and in order and all that good stuff. So there's a lot of use cases for it. We probably haven't discovered all of them, to be honest with you.
Yeah, I think AI is going to introduce a lot of them.
Yeah, AI. So I had someone, an exec, tell me that AI is actually looking at FlexCache pretty heavy. I haven't been involved with it yet, but yeah, I know. With our AI journey, FlexCache is going to be a pretty big part of that.
Well, I can kind of see it in my head. If I'm looking at this functionally, there's different stages of doing and training AI. There's training, there's inferencing, and then there's the actual interaction with it through a GPT or something like that. And each of those different things could be some kind of cache. You're always going to have an origin of data or various data sets. You're going to have a foundational model that's going to be at the very bottom of the stack. But I can see like multiple LLMs being built on top of that could be flex caches that could be pulling in data to service different GPTs, different functionalities. Whether that's BI for business intelligence, whether that's manufacturing, whatever. You mentioned EDA earlier. Like, I think EDA is going to be one of the biggest consumers of AI in the future, just from chip manufacturing standpoint.
Yeah, for sure. Yeah. So
go ahead.
I was going to say, like, the cloud bursting is really a cool example too. Let me see if I can get to that slide without. So I have an example slide here. Let me open this up. So I figured out how to do it without having to go through every slide. That's convenient. So you can see here. So because we only pulled the data that you need. So this is a big EDA play here, right? So you've got your on-prem, you got your tools and libraries over here, right? And so they submit a job up to the cloud because they need to expand their CPU presence, right? So the job's running. Well, you only pull in the tools and libraries that you need because remember, it's a block level pool, right? But then we stand up a kind of a reverse cache in the cloud where the origin is in the cloud. And so it's writing all the scratch data here. So we have a high performance write. We have a very only what's needed tools and libraries section. And none of this stuff, the logs for EDA can get huge, right?
Yeah.
Everything. But none of that is actually egressed out of the cloud just because, right? So you're going to eliminate a lot of egress charges because let's say this build, needs to be debugged. So back on prem, the developer it can see everything, right? And typically you only need like the last 100 lines of the logs to be able to debug, is what I've been told by MJ, our EDA expert, right? And so instead of having to egress all this data out of the cloud, we can just do like a tail-n100 on it, and you just saved time to get your logs. You saved egress charges, and now you can start debugging that build. Nice. So it's an efficient move of data as well.
So as an infrastructure administrator, somebody that's managing all of this stuff, what do each of these represent? Are these, I see you've got, like, I see Azure NetApp Files, Google Cloud NetApp Volumes, FSx ONTAP, This works? It's all ONTAP at the end of the day, so this all works pretty universally, right? Is FlexCache supported across all 3 hyperscalers at this point?
As long as it's CVO, you can, yes. So the only requirements for FlexCache is both the cache and the origin have to be running ONTAP, and then you have to be able to cluster peer. So I believe like Azure NetApp Files you don't have that access to cluster peer, but they're actually working on something to where pretty soon you will be able to FlexCache an Azure NetApp file. So as long as if you're running a self-managed instance of CVO in one of the hypervisors, absolutely.
And I believe FSX ONTAP has
yes,
it, or
FSX, absolutely, yes.
Because that is actually a full instance of ONTAP. It's just it's a a bare metal instance on their stuff.
Yeah, you just can't have everything abstracted away from you, right? So
exactly, with like how ANF and Google Cloud works. It's more of a just a volumes as a service in a way.
Yep.
I guess where I was going with this is this isn't just a developer scenario. This works almost universally across the cloud. So ONTAP is ONTAP is ONTAP, and if you have ONTAP everywhere, it doesn't really matter whether it's physical or a cloud instance, a virtual instance of sorts.
Doesn't matter.
So as long as ONTAP can talk to ONTAP, you can set up flex caches, right? You can do that cluster peering, regardless of locale or cloud versus on-prem. It's fair to say?
Yep. So I say hypervisor, hyperscaler, and on-prem. So because we also for hypervisor like VMware KVM, we have ONTAP Select as well, which is a perfectly fine caching side for the caches or the origin if it's beefy enough, right? So
yeah. I want to pull up a couple of questions really quick here. I think we answered this one. Arthur asks if you want to spread out content, you need to pull it to the side. There's no scheduled push. I think this was the data delegation that we discussed because we're not pushing anything. We're just revoking a delegation.
Right. So, and I think yes. So it'll be pulled on the next access if data changes. For the first access, you will have the penalty of the WAN to pull it. But there's no scheduled push by default. Now, there are some ways to pre-populate. A really popular one is XCP, our free NetApp data mover, right? You can pre-populate, but there's really not a good built-in pre-population method just because it was that's not how it was designed, right? Like I said, it was designed for just in time, not just in case. So
good call. Good question, Arthur. He threw another one in here. We have a case at our site to spread data sets to our high performance compute nodes. So I'm not sure if FlexCache is the right use case for that if you're wanting to pre-populate data. But I can see where if they're trying to access new and updated data on a frequent basis, FlexCache might be a great example for that.
Yeah, I mean, so EDA is obviously the HPC, right? And they rely heavily on it. In fact, EDA is kind of why we have FlexCache. It was introduced, I'm sure you know, way back in 7 mode days, right? We actually had something that we called FlexCache. I don't want you to get it confused. Yes, it did caching, but the new one in ONTAP 9 is a complete rewrite. But the FlexCache in 7 mode was heavily utilized by our big EDA customers. And so the fact that FlexCache didn't make the jump over to CDOT, we started getting some upset customers, right?
I also want to highlight that this is not FlashCache.
Oh, yes.
FlashCache is something completely different. So Elliott, for people, how would you describe FlashCache versus FlexCache? Because remember, I'm a new customer. I've just bought my first system. I am trying my damnedest to absorb all of these flex and snap words, and now you're going to start throwing flash words at me. There's FlexCache and FlashCache, and we don't have a snap cache, but it wouldn't surprise me one day.
Oh, it's coming, right?
So what are the fundamental differences between FlashCache and FlexCache for those that are just new to this?
Yeah, so FlashCache, and I'm not a FlashCache expert, so if I'm wrong, please do correct me. But FlashCache is going to be that was back when SSDs weren't a thing, right?
Right.
Or they were a very expensive thing. But it was FlashCache was basically a solid state drive or solid state something that you put in a cluster. So files that were heavily read would actually be served out of this solid state section in the cluster just to accelerate reads, right?
Yeah.
That was all within the same cluster. This is completely different. FlashCache had no concept of geo dispersed, right? It was all within the same cluster. This is a completely different product that, yes, it makes reads faster, but not because the disks are slow. It makes them faster because of data locality.
Yeah, and FlashCache was a physical PCI card, an expansion card that you would insert into each of the controllers that you wanted to have those read-ahead writes. And so, I mean, it was a physical device that you actually put inside your storage systems that gave you a layer of DRAM on a PCI expansion card that was a read-ahead cache. Yeah. So as similar to how we're doing so there are some similarities to it. So some of the ways that you've described how FlexCache will do data delegation or the origins to it, it will write it in, and then there's almost like a waterfall effect of cold data that comes out of the cache. But there's a concept in ONTAP known as a cache hit. So when you had FlashCache, we used to call them PAM cards. When you had cards in there, you could go in and you could do a top, and you could look at you could get your or sysinfo or whatever the command was. You could look at your cache hit ratios, and that would tell you basically, was this a waste of time and effort and money, or am I actually serving out cached reads as those requests are coming in? Again, similar use cases, but just local. If you're just serving Betty Sue in accounting all of her spreadsheets, man, load those into read-ahead cache, because she's going to have 27 of them open every day when she comes in, and they're going to open instantly instead of hourglass spinning, right?
Yep, you got it.
But the core difference being that it's local instead of being geo-dispersed.
Yep, you got it.
Yeah. So that's FlashCache. This is FlexCache.
Yes.
Believe me, I know it can be confusing. And to go back to something that my mustache keeps tickling me, to go back to something that Jeff said last week. Yes, we have a lot of flex and snap words, but there will be this moment where you kind of get it, and the light bulb will go off, and you'll have that. We all go through it. We all have it with ONTAP. And the core thing to understand is how we do stuff at the block level and snapshots. The basics of snapshots will lead you to the promised land of every flex and snap word. So if you can get that one down, everything else will sort of unlock. Elliott, do you have more slides we need to get through?
I mean, I've got a bunch of slides, but it's all where you want to go, man. So
yeah, let's get into some of the technical nuggets and of stuff of how you set this up, how you configure this. Are there prerequisites that you have to have in play to be able to take advantage of this? Is this included in the ONTAP 1 licensing? Some of that kind of stuff.
Okay, so yeah, let's tackle the licensing thing first. It actually doesn't require a license. So if you have ONTAP, you do have FlexCache. So
mic drop easy. Right there.
Yep, there you go. Yep, no extra license required. You do need to be running, and I hope you would be running at least 9.5 or later, which is when we reintroduced FlexCache from 7 mode, right? So if you're running 9.5, we've got other problems we need to talk to you about. But
yeah, you need to update your systems, because I think the oldest systems now have to be on 9.11 or something like that.
Yeah, I'm not
9.11. At least 9.10. Otherwise, your system's probably end of life, and you should get a refresh.
If you're going to be doing a stateful protocol, so it came out with just NFS v3, because remember I told you EDA was our big hitter on it, right? And anybody who knows the EDA industry knows that they are NFS v3 through and through, right? They don't do v4. I say that I'm going to get yelled at because there's a couple here and there that do SMB, or stuff like that. But for the most part, it's NFS version 3. We didn't introduce NFS version 4 or SMB access until I think it was 9.8. So still really old, right? So if you're running any kind of modern ONTAP system, you can use all versions of NFS and all versions of SMB. Basically, if it's supported by a FlexVol, it's supported at FlexCache, with 2 exceptions. NFS version 4.2 isn't supported at the cache right now, which is really just a feature extension of the NFS version 4.1 protocol. And we don't currently allow our duality feature. So we don't allow S3 access to NAS at a FlexCache yet. So
S3 access. Gotcha. Okay.
The duality.
That kind of makes sense though, because
Yeah.
you wouldn't want to be caching. It wouldn't work that way. And you know, since you said S3, this other question from Arthur came up. How's the data flow for a volume that uses data tiering to storage grid? So if they're doing Fabric Pool off to storage grid appliance, but you want to flex cache it as well, where does that sort of if then else play out?
Yeah, so you have your origin volume, right? You're going to Fabric Pool. You're gonna tier off the origin volume, right? And just go to wherever storage grid's fine. Obviously, you know, you still see that like it's still in the same spot, and that holds true for FlexCache too. The cool thing though, and they thought about this is really cool. If data that is tiered off is requested at a cache, it actually passes through the origin. It won't even populate at the origin. So it'll actually only populate at the cache. So then you're not filling up space at your origin for data that's not being needed there, right? So, but
I was going to guess, and I would have been wrong. I would have guessed that when that request comes in from a remote source or a remote destination, it's going to trigger Fabric Pool to repopulate that back in and reset the 30-day tier cycle on those blocks, and then it would be able to extend it out to delegate it out to that. So the way Fabric Pool works is it does this kind of cycle down at the block level where if it's cold blocks, it'll take them off. So instead of doing like what do you call it, file attributes and things like that, how we typically think about tiering, we're actually doing cold data blocks down at the block level and chunking the blocks into 64 meg chunks and sticking those down there. So if there's a request that comes in, regardless of if it's from a remote or from the local origin, wouldn't it just rehydrate that and reset that tier policy?
So we're getting a little bit into the Fabric Pool nuts and bolts that I'm not.
I'm asking it rhetorically, hypothetically.
Yeah. Okay. Well, then I don't have the answer.
I'm curious. Yeah. It's something I want to go dig into. That's a really good question, Arthur. But I love the concept that it'll just pass through the origin. It'll go straight from storage grid out to the remote.
Yep. I think you probably could expect, obviously, you know, that pool to take a little longer than a normal pool, obviously.
Sure.
But yeah. Yep. Should be transparent. I mean, really, one of the things when FlexCache was created, we didn't want people to even know they were accessing a cache. I mean, you shouldn't have any difference in your locking. You shouldn't have any difference in, you know, how you actually interact with the data. And so that was one of the guiding principles when they engineered it. So.
Anastasi said FlexCache on 7mo was DRAM cache. I don't remember FlexCache. I think it was specialty at the time. I only remember the PAM cards flash cache.
Yeah,
PAM cards eventually got productized into a feature called FlashCache.
Man, I'll tell you this: when I was a NAS escalation engineer, I came in right in like the 8.1, 8.2 days of CDOT, and so whenever like a 7 mode case came in, I was like, oh man, I don't know anything. It's like I wasn't trained on this. So I basically FlexCache would come in and I would throw my hands up then, right? I'm like, I don't know. Let me get somebody who's been here longer. So I don't know a whole lot of the details. I do know we used a completely different kind of paradigm to cache it over to another HA pair or whatever, but there's a different proprietary protocol between the two. I'm going to call them clusters. They weren't clusters then, but yeah.
What are some other gotchas or things people that should know about FlexCache?
So a lot of people like to paint FlexCache as the the savior for all workload issues, right? It's like anything else. It's not meant for everything, right? If you have a bunch of people trying to write to the same file, we honor locks, so and we have to orchestrate those, and that takes time, right? So you're going to get a lot. So contended writes, if you're constantly contending to write to the same file, FlexCache probably isn't a good thing, right?
Yeah.
If you currently, we're working on this, if your workflow really depends on read after write, probably not a good thing, because if you think about it, the writes have to go to the origin, and then you got to pull them back. So which we could probably start talking about writes, which is important because we just released a new mode of operation for FlexCache called write back. So let me give you a little history here. So let me go to another slide here.
Yeah, and if there's anything new with like the latest and greatest in ONTAP 9.16 that you want to highlight, that'd be awesome too.
Yeah, so not for FlexCache, there's not. It was more of let's catch up on some feature not really feature enhancements, because that means something new, just enhancing what we already have. So 9.16 was pretty light on the release for that's right around. Okay, so there's two modes of operation for FlexCache, and this is maybe something I should highlight. Is a lot of people think of caches as read only, right? And that's not the case for FlexCache. You can mount, or if it's NFS, you can mount one volume, the cache, or you can map one share, which is the cache, and that will be read write. Okay, so but then we have two modes of operation for writes. By default, it's called write around, and then in 9.15 we introduced something called write back. So let me walk through a couple slides of this on how this works. So in write around mode, essentially what happens is the cache, oh, come on now. It's not going to let me do my steps here. There we go. All right. So I figured it out. All right. So here's write around. So the write client, I'm not going to be able to do that one. I will do it with my mouse. So right here is going to go to the cache, but the cache is actually going to intercept it, and it's going to turn it into a waffle call and forward it to the origin. Okay. And then once the origin has it committed to stable storage, then the origin will respond back, hey man, I've got this committed to stable storage. And then and only then can the cache actually reply to the client. So you get this weigh-in penalty in write around mode. So
is this a situation where the origin needs to be updated, but the cache has the newer version, so you have to push it back up to the origin?
Well, no. So in write around mode, no data actually lands at the cache at all.
Okay.
It's literally passed through. So
if writes and updates are made to the file that's being accessed at the client level, that write is just going to go straight back to the origin.
Yep.
And if it's requested again as a read, then it'll get cached with FlexCache.
Yep, you got it. Yep.
Got it. Okay.
So obviously, we wanted to get weigh-in or LAN-like performance for writes. So let me go to this slide now. Hopefully this animation will work. All right, so here's write back, which was introduced in 9.15. So now it actually gets committed at the cache, and then asynchronously, we're going to flush that back to the origin. And now we have locking delegations, and those data delegations are really important here, right? Because if something is accessing this file at a different cache, it needs to know that, hey, this is being updated somewhere else, so you can't access this right now. And so we could get into all those weeds if you want with lock delegations and data delegations and how they work. But if we want to keep it at a higher level, just know that you will never, even in write back mode, you're guaranteed never to access old data. And everything, it doesn't matter which cache you access, you'll always access the same data. It's not like one cache can get out of sync or anything like that. Like I said, consistency, currency, and coherency are always maintained 100%. So
that's always the concern with stuff like this, isn't it? It's that somebody's going to be updating the origin at the same time that somebody's going to be updating the local cache copy. and then you get into a who's right finger pointing
Yeah.
contest.
Yeah.
And
Yeah.
you end up in, false epsilon scenarios and stuff like that. And I'm looking at it like, how do we deal with that? Yeah, let's get a little bit into the weeds of like, how do
Okay.
we deal with that? How does
So,
ONTAP know which is the single source of truth?
yep. So let's go here. All right. So lock delegations. This is the big thing, right? So keep in mind, let's take FlexCache out of the picture, right? And let's go with a stateful protocol where locking is mandatory, okay? Because we all know NFS version 3 is advisory locking, right? Last writer wins. And that's still the case with FlexCache. Like I said, we wanted people not to know that they're accessing on FlexCache. So locking is going to work as if FlexCache was out of the picture. But the origin, is the single source of truth, but it also orchestrates the locking. And so we have lock delegations. And what this is the origin can hand out a per file authority to a cache that allows that cache to hand out locks as it sees fit for that file. Okay. So it's not a lock that it's handing out. It's a lock delegation is handing out. And there's two kinds that we can hand out: a shared lock delegation, which is a read lock, right? Or an exclusive lock delegation, or a write lock. So if a cache has a read lock, it cannot provide an exclusive write lock to a file. Okay. If it has a write lock, obviously it can hand out write locks as it sees fit. Now, important is exclusive locks. There can only exist one exclusive lock delegation for a file at any time, anywhere in the mesh, at the origin or any of the other caches. That way we avoid a couple things here, right? Yeah, and you cannot coexist with an SLD. That's a good point.
That makes sense.
Yep. So these are the basically, by doing that, we negate the need to ever have to do any kind of like conflict resolution, because we had a dual writer scenario, where they come back into the origin. It's like, oh, now, like sync and share is really bad about that. You got basically two copies of the file. Now it's being synced back to the center, back to central, or whatever you want to call it. And now you've got to do, okay, well, these are different. Which one do we want to keep, right? We're never going to get into that scenario with FlexCache, because the locking delegation prevents a two-writer scenario. So
it's just not something you ever have to deal with anymore with these sorts of guardrails built around it.
Exactly. So, I mean, it's exactly as if two clients are writing at the same flex vol, right? If someone takes an exclusive lock on a file to write to it, that other client's not going to be able to access it, right? Because
the simplest example I can think of is if you try to open a Word document, if two people tried to open the same Word document or Excel spreadsheet or PowerPoint file or something like that, you're going to get those Microsoft Office warnings that are just like, so-and-so already has this file open. Do you want to open it in read-only mode? And then it just turns everything into a mess and you get split-brained. This prevents that from ever being possible in the first place, which is fantastic.
Yep. So basically that's really, the lock delegations, it can get expensive. And that's why I was saying like conflicting rights, think about it. Now we've got these exclusive lock delegations flying around all across the globe, right? So we don't want highly contended rights, are not a good example, good use case for FlexCache, because of the delegation overhead for that, right?
Yeah.
And then, so let's say you are in write back mode, okay? And you've got all this data being written to file A. And then someone at, then another cache requests this file. Well, the data, we're going to not allow them to access that file until that write is completed and it's updated at the origin, and then they can access the latest data. So
got it.
Yep. And I've got some slides that actually they should, hopefully they work. They go over this in pretty good detail. Why don't we just go over that? But here's the data delegation. That one's pretty simple. We already went over that. That's the flag that says the data for this file is up to date. You don't have to go back to the origin, right?
Pause right there for 1 second, because we did have one question come in here that I wanted to hit on myself. So I'm glad he brought it up. Do we ever flush out? Is there a expiration date of the cache? Is there a start over point? Like, where do we start cleaning up caches, or is that thing that just isn't necessary?
So as far as eviction of cache, we will evict when the cache breaches 90% full. We'll start evicting the least recently used file to make room, right?
Okay.
That's on by default.
And that's based on the volume size?
The volume size, not the origin
Okay.
size, but the cache size, right?
Gotcha.
The other way you can do it is you can set an 8-time scrubber period, right? So if this file hasn't been touched in X amount of days, I believe right now the most granular you can get is days. Go ahead and start evicting it from the cache. So those are our two ways.
So I could put a 30-day limit on there. If nobody's touched it in 30 days, it'll evict it from the cache. But if they request it again at any given point, it just does a pull again.
Yeah. Yeah, it's in when we say evicted, remember it's still going to look like it's there, right? It's not like it's disappeared from the cache. So it just doesn't have any data blocks. So those are the two ways for eviction. Now, can you bring that question back up real quick? Because I think he may have been asking a different thing here. So he's asking, how long does the data stay in FlexCache when doing write back? And so what I think they're getting at here is how aggressive are we pushing back dirty data to the origin, right? And so there's a couple. It depends if you're using NFS version 3, which is a stateless protocol, or if you're using SMB or NFS version 4, right? So no matter what protocol you're using, we're going to try to not maintain any more than 20 megabytes of dirty data. Dirty data is just data that exists at the cache that hasn't been flushed back yet, right? We try to keep 20 megabytes and no more. Of course, sometimes we're going to get more, but we will always try to keep 20 megabytes. That last 20 megabytes, when are we going to push that? Well, for stateful protocols, it's going to be on close. So the writes are going to the file. It's pushing back. And then we have this 20 megabyte chunk that hasn't been pushed back. File gets closed. We push that last 20 megabytes back. Okay. For stateless protocols, obviously there's no concept of close or open, right? So for that, we have a timer, and it's a 5-minute timer, which seems like a lot. But if that file has been idle for 5 minutes, we're going to flush that data back. But if another person requests that file at a different cache or at the origin, we're going to pull that data back immediately. So I think that's what they were really going for with their question. If not, I just gave you a breakdown on how that works.
Crash course, yeah. Following that one, what is actually the consistency point for data flushed to the origin from cache? How is that? I think we talked about that as the source of truth a few minutes ago.
What is the consistency point for data flush? I feel like that's I don't know how to answer that. So because the consistency point on the front end is going to be the same. I mean, when I think of consistency points, I'm thinking of like CP flush, waffle cache flushes, right? So it's going to be on that time frame that I just went over, right? We're going to push it back on those times. So
he asked a similar follow-up as well, like, is there any chance of data loss if there's a disconnect? Like, how do we handle that stuff if you lose your peering?
Yeah, so there is, obviously. So in write around mode, there's not, okay? Because we're not going to get acknowledged the write until it's actually committed to the origin, right? But in write back mode, there is a window there, right, where data could be dirty at the cache, and then the network gets broke, and now we can't get it back to the origin, right? And so in that case, we have an option. We obviously can't hold a file hostage forever and not have a way to clear it, right, and allow other caches that are still connected or even the origin to access it. So in that case, we do have an administrative option for the storage administrator to go in and manually basically break that lock. And it does come with the warning that, hey, when you do this, we're going to discard any data that has not been flushed back, and you will lose data. But there's really no other option, right? So
yeah, it's a good point. And I guess at that point, do you kind of have to go file by file and see which one has been updated, which one has been done, or is it just a sit around and wait for the connection to resume and go in and tell it to do some kind of resume operation? I don't know.
Yeah, that's actually a good question because I haven't had to do it yet. I don't know what it looks like, and I don't know the granularity of it. That's actually a great question that I need to follow up and learn that myself. So
Good deal. Let's see. We have one more here. In an HPC environment, when I'm reading and writing lots of data, then reading and writing lots of data, then reading it, will the written data be in cache?
in write back mode, yes.
In write back, yes. Okay.
Yes. That's so in write back mode, you can do read after write workloads with 9.15.1 P5 or later. So essentially, I think what he's asking is like if you write to a file, and it's not all been flushed back to the origin yet, can I still read that file at the same cache? And the answer is yes, with 9.15 P5.
But not in the write around mode.
Not in write around. No, I mean you can, but it's going to have the penalty of pulling it back from the origin. Right?
Yeah, it's going to do all the way. It's going to come all the way back around full circle. Yeah.
Yeah, exactly.
Cool. Good questions, guys. Keep them coming. All right. You were, before I interrupted you, you were jumping around to something else. I just wanted to make sure that we were covering things here. We got about 5 minutes left. Just making sure that, is there anything else that you want to highlight? Any gotchas, any considerations before people start implementing this?
So I have some use cases, some best practices, right? So write back is not free, right? So anything that speeds stuff up has a penalty somewhere else, right? And the penalty is it does have more overhead. So you need to, we like to tell people, compare your write around through write back. And if your performance is about the same, or if write around is acceptable to you, it's probably better to go with write back. Okay. Just because the overhead of write back a lot of times will negate any benefits you get from it. It's not always the case. I shouldn't say a lot of times. I should say it can negate the benefits you get from it. So when you're deploying this, test your production workload with write around, write back. If there's a tie, go with write around. Yeah, number two is, it seems obvious, right? But make sure you have enough data, enough size in the cache, so you're not evicting constantly, cache thrashing, right? If you're always over 90%, you're going to always be evicting stuff. And you also need to make sure there's enough room in the origin as well, because there are some metadata files and stuff like that that are written. If we can't write those, things start getting a little weird, right?
Well, earlier you said the caches are just flex vols on other systems. Do the same auto grow and that kind of stuff policies apply to just any other flex vol, or is there limitations to that with FlexCache?
Well, first of all, there's actually a flex group under the hood.
Fair enough.
Yeah. But yes, you can auto grow a FlexCache and all that. Which is perfectly fine. Just know that you won't ever evict at that point, right? If you auto grow and you never breach that 90% threshold, you won't ever evict, which could be good, right? That may be exactly what you're trying to go for. But yes, all those, I mean, since it is just a flex group under the hood, all that stuff applies. The only thing you can't.
But then at a certain point, you can just set up hourly snap mirrors, and if you've got big enough storage to do that kind of stuff, right? You don't even need to do the caching if you just want to have massive volumes on it everywhere. You just replicate it then.
Yeah, exactly.
Cut out the middleman.
One for one cache. I mean, which is one thing that there's two things that I mean, there's more, but a snap mirror obviously isn't read writable unless you break it. Right? So this you can write to it even if it's in write around mode. And the other thing is the lowest delta you can have for SnapMirror, I believe, is 5 minutes, right? So if you need quicker access to up-to-date data, then FlexCache is good for one-to-one caching. Yeah. Make sure, so number three is make sure you should be running the same ONTAP version for your cache and your origin clusters. You don't have to, that's not a hard rule. Just keep in mind that, you will not be able to access any features that if you're running a lower, like say you're running 9.14 at the origin, 9.15.1 at the cache, you're not going to be able to access any 9.15.1 features. You're only going to be able to access 9.14.1 features.
Because the origin isn't updated yet.
Exactly. So the lowest common one is what you're going to be. The lowest ONTAP version, that's the feature set you get. So
gotcha. So it's different than SnapMirror, where your destination has to be the same or higher,
right?
Than your source. Okay.
Yep.
What was I going to ask? Oh, I just thought of a question. I forgot it. I'll come back to it. Okay, keep going. Let's do the fourth one here.
Okay, yeah, it's just so from a NAS perspective, right? You always want to have access to the same centralized name services. I mean,
Yeah.
you don't. I'm not talking to the same actual physical server because these could be on different sides of the world, right? But a replicated database of your Unix usernames, UIDs, or your Windows. So just make sure you have that.
Or AD if you're doing AD.
Yeah, Active Directory. Yep, you got it.
All right. Couple more questions. You got some more to go over here?
No,
I want to make sure we
I
get
mean,
through your stuff before we do any more questions. But yeah, any other best
I mean, I've
practices
got
or
all.
gotchas to let people know?
Yeah, I mean, so I guess I do have a worst practices slide.
Oh yeah, these are awesome.
Yeah, so SnapMirror can be a data hog, right? And so a lot of times your network team is like, "Hey, I'm going to put the throttle on that thing," and so FlexCache actually uses the same TCP ports as SnapMirror. So if your network team is throttling TCP ports 1 on 105 or 1 on 104, you're going to throttle your FlexCache, and that doesn't play well, right? So if they do need to throttle SnapMirror, go ahead and try to convince them to let you do it in ONTAP with a SnapMirror global throttle or something like that, and not do it at the TCP layer in the network. I already went over number 2. Conflicting writes are just going to cause lock thrashing. Snapshots are not taken at the caches for obvious reasons. They're not full files, right? So, but a snapshot at the origin will, in write back mode, it has to recall all that data that's dirty before it can take the snapshot. So if you have a lot of outstanding dirty data and you have a heavy snapshot a very quick snapshot cadence, like you're doing it every 20 minutes or so, that could become kind of cumbersome. So be wary of that. And then obviously the read after write workloads that I was talking about for write around enabled caches.
So okay, what is the best practice then for protecting an origin volume that has one or more flex caches geo dispersed to it? So if we don't want to do a lot of snapshotting or backing up or mirroring off of an origin volume, what is the best way to protect that?
I mean, you can still use snapshots. Just try to take the snapshots when you know that the write, and then this is only for write back mode, right? Write around, everything's already there, so you don't have this. But for write back mode, just try to do it during, a time when the writes aren't so heavy, so there's not so much dirty data that has to be called home.
Got it. Okay.
Yep.
Yeah, write around mode sounds like it would be the 90th percentile, good enough, the right thing move for just about everybody, with the few exceptions being the 10% of like specialized workloads that really need write back, that are doing a lot of stuff remotely.
Yep, you got it. Absolutely.
Or certain certain hybrid workload scenarios, I could see write back being used pretty heavily. And you're probably going to invest in an ExpressNet or a direct connect or whatever direct circuit to have that kind of connectivity back and forth between the cloud. I could certainly pick out a lot of instances where I see the cloud being a big part of this story. Whether it's development, whether it's AI, whether it's shared workloads, data processing, business intelligence, that kind of stuff. Yeah, I can definitely see that.
Yeah, and people are surprised actually how well write around works, because it'll actually work faster than writing directly to the origin a lot of times. Because
if you got a really slow system, maybe it's quicker to just do the write around and then send the cache hit back down.
Yeah, well, and we have we're using SnapMirror kind of on the back end. I mean, it's not SnapMirror. I don't want to confuse people, but we have highly parallelized TCP connections between the two clusters, so we can get our bytes and flight up. And it's not actually NAS traffic going over the WAN. It's a proprietary waffle kind of protocol, so you don't get. NAS kind of sucks over the WAN, right? Especially SMB. It's really chatty and it gets exacerbated, the performance it does over the WAN. So since we're terminating at the cache, and then it's not NAS going to the origin, you actually get a performance boost.
Does ONTAP or Waffle or anything do any kind of particular prioritization of for FlexCache or for anything like that, or is it just first in first out kind of stuff?
Yep, there's no special prioritization. No.
Okay. Pull these back down. So Khalid asks, multi-protocol access on a cache, same cache volume, any challenge with locks in such cases?
No, so this is going to be the exact. Goes to that paradigm where we want you to be able to access it just like you would at normal FlexVol Flex Group. So multi-protocol, 100% supported. Nothing to worry about.
There you go. Nice and easy.
Yeah.
And let's see. Will a Flex Group source with Q trees map to a Flex Group FlexCache?
Okay, so Q trees actually right now they're just going to show up as directories. You don't get all the Q tree goodness of the cache. So I think we're working on that, but yeah, as of right now, Q trees, they're there. You'll see them, but you don't have the Q tree. Like, it's not actually defined as a Q tree at the cache. So
yeah, there you go. Well, Elliott, this has been fantastic, man. Thank you so much, guys. If you have questions, be sure and come see us in Discord, because I'll be sure and Elliott, if you're not in there, we need to get you in there for sure.
Yeah, I think I am.
We'll
talk after and make sure.
I do want to highlight the designed for just in time, not just in case. Like, that needs to be on a t-shirt.
Yeah.
You guys should make some FlexCache t-shirts. I really like that.
Cool.
It's one of those inside baseball things that administrators understand that a lot of people kind of just blow their head up. But yeah. This has been fantastic. Happy holidays to you and yours, my friend. Thank you for being on the show. Thank you for being our final episode of the year here. And this has been fantastic. I hope you all enjoyed it as well. And we'll catch you guys on the next one. Elliott, thanks so much for being a part of it. I appreciate it.
Yeah, thank you. Happy holidays.
Happy holidays. All right, well, there we go, guys. 2024 is in the books. Closing it out with an excellent one today on something that I was learning stuff about during this whole thing. FlexCache. I learned some new stuff today. I didn't know if that was possible anymore. But yes, it is. I see you guys have some more questions coming in. Come join us in Discord. Bring them over there. We'll keep the conversation going with Elliott and ourselves. Happy holidays, everybody, no matter where you are around the world. We love you guys. Thank you very much for being part of this awesome community that we have here at NetApp. And we'll see you guys in Discord. Follow us on Spotify. Subscribe to all the channels. You guys know how to do all of that stuff in 2024. My name is Nick Howell. Thanks so much for joining us. We'll see you guys next year. Take care.